In this lecture, we are going to continue our discussion of algorithmic trading. The previous trend-following strategy can be thought of as having hyperparameters, but not parameters. There was no learning, and no statistical model was involved in the strategy. In this lecture, we will be moving to machine learning-based strategies. We'll see how building a predictive model of future stock returns may be able to help us trade better. Now, you may recall one lesson we learned earlier in this course. It was that predicting stock returns is pretty hard, especially predicting multiple days into the future. But what if we only need to predict one day into the future? This, in comparison, may be an easier task. In our current scenario, this approach is plausible because, just like the trend-following strategy, we are going to update our position on a daily basis. That means we can use all the data up to the current time step and only predict the return for the next time step. Our decision to buy, sell, or do nothing is updated every single day. Therefore, we only have to worry about predicting one day into the future. Okay, so that being said, I think our problem becomes pretty simple. We're going to build a predictive model to predict tomorrow's stock return and buy, sell, or do nothing accordingly. So if we predict that it will go up, then we buy, and if we predict that it will go down, then we sell. Note that instead of the auto-regressive approach we discussed in the time series section, we are now going to take a different approach. As you know, the S&P 500 contains approximately 500 stocks. It is plausible that the previous returns on these 500 stocks could predict the next return of the total index. Note, however, that this is not guaranteed, it is just an idea. In actuality, I would remind you that one of the major themes of this course is it's not about the model you use, but the data. If you use non-predictive data, then it doesn't matter how good your model is, it just won't work. But the data you could use really consists of anything in the world, and so you really have to consider that when building these models. Now, obviously, using all the data in the world is not feasible for a course like this, and the possible combinations grow exponentially as we consider more sources of data. Even with 500 stocks, the number of combinations we might try is infeasibly large. Therefore, what I'm going to do is pick a small subset of stocks. Now you might ask, did I do anything special to pick these stocks? The answer is no. I simply chose some companies from the S&P 500, which have the largest market cap. Another question you might have is, why not just use all 500 companies and let the model do the work? The answer is that this will overfit. Now, the reason why is beyond the scope of this course, but if you want to learn more, you're encouraged to check out my in-depth series, where I go through the math and theory behind algorithms such as linear regression. Now obviously, that being a course all by itself, we don't have time to discuss that here. However, I will remind you of my motto: machine learning is experimentation, not philosophy. If you think something will work, you shouldn't try to guess what the outcome might be. Simply trying it and observing the result is always a superior choice. Another question you might have is, why am I using stock returns and not stock prices to predict the S&P 500? The answer is again outside the scope of this course, but machine learning models and statistical models are generally not good at extrapolation. As you know, stock prices in the market are generally going up. If you train your model on prices in the range $100 to $200, your model might learn what to do for that range. But if it goes up to $300 in the test set, your model has never seen that before, and it doesn't know what to do. Returns, however, as we learned, are more or less stationary. Therefore, they are better candidates for input features. Now, some of you who have done machine learning before might ask, why can't I just normalize the data? For example, put it into the range 0 to 1. In fact, this would not work, and I would encourage you to think about why you will still have the same problem. Okay, so now that we've done all the groundwork, let's see what our data frame, paper trading code, will look like. Suppose we have a data frame full of stock prices in each column for various assets in the S&P, as well as the price for the S&P itself. From this, we can create a new data frame containing only the corresponding returns. Note that because we're calculating returns or log returns, the first row for all of these columns will be null. Therefore, no inputs or outputs will exist for the first row, unlike the trend following strategy. The next step is again to shift the S&P returns backwards by 1. As you recall, data frames and arrays are easier to work with when everything we need to compute on is in the same row. Remember that we are using the returns of the input stocks to predict the next day's return of the S&P. Therefore, it's easier to have all the inputs and corresponding outputs in the same row. Once we have this, it's easy to split our data into train and test. We can simply make the last 1,000 rows the test set, and everything before that the train set. Next, what we're going to do is take all the columns from the train set that belong to the input variables and call that xtrain. We'll call the S&P returns column ytrain. Then all we need to do is create a machine learning model like linear regression and fit it on xtrain and ytrain. Note that you've seen this before in this course. Now you might wonder, what will happen if we use more complex models or different kinds of models? These will be discussed in a future lecture, so just hold that thought for now. Okay, so the next step will be to use our model to make predictions. Note that we don't actually need to store the predictions themselves, just whether they are greater than or less than 0. If our prediction is greater than 0, we will buy or just remain invested. If our prediction is less than 0, we will sell or just remain uninvested. So at each row of the data frame, we will know whether we are invested or uninvested based on the sign of the prediction. Once we know whether we are invested or not, we can do the same thing we did previously, where we multiply the invested column by the returns. We can assign that to a new column called algo return. The total cumulative log return is then just the sum of this column. Okay, so that's the algorithm for building a machine learning based trading strategy.